Good day, learners. This is the answer to our trick point in our previous video. You can pause the video to see the answers clearly. The problem is, Reeds travel from church 40 meters to west, 50 meters to south, and another 40 meters to west to reach his house for a time interval of 16 seconds. Solve for his average speed, instantaneous speed from point B to C, average velocity, and instantaneous velocity from point C to D. Below is the illustration of Reeds as he travels. Let's solve first the average speed. We have the following given. Total time of travel 16 seconds and total distance traveled is 130 meters. Take note, we get the total distance and time of travel because we are solving for the average speed. Its formula is equal to distance divided by time. Our distance is equal to 130 meters divided by the time, which is 16 seconds. The average speed of Reeds is equal to 8.125 meter per second. Next, we have to solve for the instantaneous speed from point B to C. The given time from point B to C is equal to 6 seconds, and the distance from point B to C is equal to 50 meters. To solve for the instantaneous speed, we have the distance from point B to C, which is 50 meters, divided by the time, which is 6 seconds. The instantaneous speed of Reeds from point B to C is equal to 8.33 meter per second. Next, we have to solve for the average velocity of Reeds. By looking at the illustration, we can conclude that his displacement is equal to 50 meters to south with a time interval of 6 seconds. For solving his velocity, we will use the formula velocity is equal to displacement divided by time, which is 50 meters to the south divided by 6 seconds. The average velocity of Reeds is equal to 8.33 meters per second going south. And lastly, we will solve for the instantaneous velocity of Reeds from point C to D. The given are the following. Displacement from point C to D is 40 meters going west with a time interval of 5 seconds. Using the formula, velocity is equal to displacement from point C to D divided by its time interval. Reeds instantaneous velocity from point C to D is equal to 8 meter per second going to west. You learn that motion can be described in different ways. It can be distance and displacement, speed and velocity, and in this video you will understand or learn to describe motion using acceleration. But before we that, let's have first a short intro. Objects around us move with respect to a reference point, and they are moving constantly or changing in terms of speed, direction, or speed with direction, which is velocity. This means that the object is accelerating. Acceleration is the rate of change in velocity of a moving object per unit of time. Acceleration also tells us how quick an object is moving, either speeding up or slowing down. For what instance an object experiences acceleration? First, constant direction but the magnitude of the velocity changes. For example, a car is traveling with a speed from 20 meter per second to 35 meter per second. Second, the same speed but the direction changes. For example, a car is traveling with a constant speed of 20 meter per second to east, then 20 meter per second to south. And lastly, an object experiences acceleration if both direction and the speed changes. For example, a car is traveling with a velocity of 20 meter per second to west and then turn to 30 meter per second going to south. Acceleration can be positive or negative. A positive acceleration is an increase in speed or velocity, while a negative acceleration is decrease in speed or velocity. To solve for acceleration, its formula is acceleration is equal to change in velocity divided by the time of travel. Or we can denote it as small letter a for acceleration and change in v for velocity and small letter t for time. We can have the formula a is equal to change in v divided by t, or is equal to vf minus vi divided by t or time, by which vf stands for final velocity and vi is for initial velocity. Now let's try to solve a problem related to acceleration. As the traffic light turns to green, the car starts to increase its velocity from 0 meter per second to 40 meter per second, going east in 3 seconds. Find the acceleration of the car. The following are the given of the problem. Initial velocity is equal to 0 meter per second, final velocity is equal to 40 meters per second, and the time is 3 seconds. Acceleration is equal to change in velocity divided by time, or final velocity minus initial velocity divided by time. Acceleration is equal to 40 meter per second minus 0 meter per second divided by the time, which is 3 seconds. The acceleration of the car is equal to 13.33 meter per second squared going east. Let's have another problem. A car is traveling north at a speed of 60 meters per second. When the dog suddenly crosses and the car applies brake, his speed changes to 10 meters per second at a time interval of 2.5 seconds. Solve for the car's acceleration. The given are the following. Initial velocity is equal to 60 meters per second. Final velocity is 10 meters per second. A time interval of 2.5 seconds. Solve for the car's acceleration. Acceleration is equal to change in velocity divided by time, or final velocity minus initial velocity divided by time. Acceleration is equal to 10 meters per second minus 60 meters per second divided by 2.5 seconds. The acceleration of the car is negative 20 meters per second squared going north. Take note, its acceleration is negative. It means that the car is slowing down or experiencing deceleration. When an object increases its speed, it experiences acceleration, like in our number 1 example, which is 13.33 meter per second squared going east. While in our example number 2, it experiences deceleration because its speed is decreasing, by which its acceleration is equal to negative 20 meter per second squared going north. Before I end this video, let's first have a short recap about what you have learned in this video. Acceleration is the rate of change in velocity of a moving object per unit of time, with a formula of A is equal to final velocity minus initial velocity divided by the time it took to travel. An increase in speed will have a positive acceleration, while decrease in speed will result to negative acceleration. For being with me in this video. I hope you learned something about acceleration. If you have some questions or any topic that you would like to discuss, you can write it in our comment section. A big shout out to Kinsley Okansi. Thank you for having a good feedback in our previous lesson. Thank you and God bless.